Hello, so directly let's continue with our snake project. So here is where we ended the last time. As I told at the end of the last video, I had to add here a wait loop so that the program is not proceeding too fast. But basically this is where we ended. So, and the first thing that I want to add here is just the check for the end of the game. So until we have here something better, let's also directly just jump to the main loop. So what we are checking here, you remember this plot function also returns in the accumulator what the character was that we have overwritten as a kind of side effect. I mean, it's not that proper. The proper way would be to have also a peek or a scan function, scan on x and y and call this before, but this makes just lets us reuse most of the function of the plot function. So we are just checking the accumulator if it holds this value. What does it mean if it holds this value? You see, we are also drawing the snake with that value. So this means if we have written the head on a field holding that value, we were driving in our own body. So this is then end of the game. Actually, we are just jumping to the main loop, so nothing happens, but we will change this. And here also just let's do, so this is I think it's the heart, the character ASCII of the heart, and this is just the food. So if we have written on this, we have eaten something. So here also should happen something, but we need to implement this later. So let's just jump over this. So if it is not equal that, then we are just jumping over this. And if so, we also need to do something. So yeah, I can show this. So we do, at this time we do nothing. So there is really the command nope. Eaten a heart. So and then we are again here. So we need also a command for this. So just use this nope. Nope is just a command. Don't do anything. So the processor is really doing nothing for one loop. Good. That is the one thing. That was the easy part. And now the complicated part that we want to do today is we want to care about the tail of the snake. And in order to do so, I have added 4 additional variables. So one is the pointer to the tail. So this is basically pointing to where the end of the snake is. You also can read from here more or less the length of the snake. Then we will later need a growth counter where we can count if the snake is growing. And then here the important thing is where we store really the whole body of the snake. And I have a variable to store the x values and a variable to store the y values. Now, in such a variable, you only can store one value, but for the snakes, we need several of those values, you know. So this is the reason why the memory areas in reality are far away from each other, and we will use all the values here. So we will use the 3100 and the 3101 and the 3102 and so on, all the way up to 3100FF to store the x values, and the same is for the y values. So, and what we also need to do, at least now, we should have done this also in the last lesson, but I have not thought about it. We should give our variables initial values. So the tail pointer will be 0 at the beginning. So at the beginning, the snake has the length of 0. And we set the growth counter to 5, so we want to have an initial growth or initial length then of the snake of 5. So basically this just means that the tail will start to follow the snake after the head has done 5 steps. Then we will set an initial direction. This is also the reason why in the last lesson the snake was not moving from the beginning on. And here, this is what we should at least have done already the last time. We set an initial value for the x and the y. I'm still surprised that it worked at all, so without setting this the last time. Okay, and now the algorithm. So what we are doing here, maybe I should start with the idea first here. So what we are doing all the time is we are just in each loop we are taking the x position of the head and the y position of the head and are storing it into our body variables. And you know, so here is no magic in it, so it's really the very first value. So this is the 3100 and this is the 3200. If we now would continue only like this, we would only store at this location and we would not completely store the whole body of the snake. Because of this, we are first doing the following. And now again, maybe I should tell you, this is not the most efficient way to do it, but this is the most easiest way to understand what is happening. So what we are doing is we are setting first our X register with the actual length of the snake. So imagine if the snake would now have the length 5, the X would now have the value 5. And then we are looping through this. So here we are just making a check. If the length is 0, we don't want to do anything at all. But in other cases, we are doing the following. So we are loading the value from where we stored the x values of the body, but we are taking the value 1 less. Yeah. So for example, in the very last loop, we will take here the value from 3100 and store it to 3101. So this means what was the last time the head of the snake is now the second part of the snake. And we do the same for the y. And you see here a new R version of addressing. So here is the STA. We give here a position. So this is now really a memory location, and it is given with a 16-bit value. And we have in addition the X. And the X is an additional offset. So this means, you remember, we have here set the length to X. So it begins, so for example, if the length of the snake is 5, it begins to store the value from 3100 and the offset of X 4, so 3104, and stores it in 3105. And then in the next loop we are reducing x by 1, so then it stores the value from 301,003 to 301,004, and so on until x is 1, and then it stores the value from 3100 to 3101. And if it's 0, it jumps out, and then it stores again the head at the first location. So it moves the body of the snake in the memory downwards. So, and why are we doing all this? We are doing this because we need to delete the snake at the end of, so where the tail is. And this is what we are doing here. So again, we are setting x to the tail, and then we are loading just the y value, and now we are taking really the x, which is the length, so we are taking the very last value and are copying it or are placing it into y. Then we are loading the very last x value of the body and placing it into x, and we are loading the empty character, so this is the ASCII value for space, into the z value, and then we can use again the plot function, where we are now plotting at exactly at the tail of the snake the empty character, and this is how we delete the snake. And this already would work fine. The only problem is that if we do it like this, the snake is not possible, or it's not possible for the snake to grow. So let's place something a little bit around it. So what means growing for the snake? Growing means just that we, as long as we want the snake to grow, we skip this part of code, because then the tail will just not be deleted. So we are looking for our growth counter, and as long as the growth counter is not 0, we are jumping completely over this code. So the tail will not be deleted, but the head is still moving, so the snake is growing. But what we also need is then, so we are jumping from here down to here, and we are decreasing then the growth counter, because of course we want the growing of the snake to end at some point. And so you see, you will always jump over this and decrease the growth counter until the growth counter is 0, and then you will go into this code. And what I have added here is first let's go to this. So here you decrease the growth counter, and what you also need to do is to increase the tail, because the length of the snake is getting bigger, so you need to increase the pointer to the end of the snake. And that's it. And these 2 lines I have added are only a trick, because what you want to do, if you are no longer growing, you just want no longer to change the growth counter and no longer to change the pointer to the tail. But to get not a too complicated control structure, you are just doing the following. You are decreasing the tail and increasing the growth counter, because after this you are falling to the code that is again increasing the tail and decreasing the growth counter. So this is just doing this inverse. If you would have not wanted to do it like this, you would have to introduce an additional label and again to jump over those 2 commands. And so this is the only reason why I did this. So, and now we also can improve here what happens if something is eaten. If an heart is eaten, then we just want to increase the growth counter, because then the snake again starts to grow. So we are increasing here the growth counter. So this means if we are going back to here, then one time this will be skipped, so the size of the snake will be increased by 1. So, and now to test this, we will just add some food on the screen. I don't want to go into in this basic class in the topic of random numbers, which we would have to do if for the seeding of the food. So we just place manually a bit of food somewhere, and that's, I think, is enough for testing. And then you already can see how this works. So here you can see the result. It's not exactly the result. I mean, now it's about 1 hour later, and I had to fight with a really strange bug. I will show you directly why and how. And this is also what gives me the hint that so the next lesson will go about all the commands that are new in the Commodore 65, now that you have a background on assembler. And then we will, I think we sure need to go for debugging of assembler on the Commodore 65. Although the problem that I had would not be to find that easy with those debugging techniques. I think it's necessary to find some debugging techniques. So, okay, you have now the basics to write small programs. I will show you what the problem was. Maybe some of you already have seen while I was writing it. So if you remember here, I had written it in this way, and so on, yeah. So I was writing to a completely different memory location. I'm also not sure why it happened then in this. I mean, the program behaved in a complete strange way, and it was really difficult to find it out. So for this reason, in 2 lessons we will learn a little bit on how debug. I mean, we don't have such comfortable things like breaking points or also like we would have for the Commodore 64, but we are not completely helpless. And in the next lesson, this will be then be again more schematic lesson, or structured, or however you would call it, where we go step by step through all the commands that are new in the Commodore 65. So in general, I will no longer do now an introduction of assembler in general. I will focus on the Commodore 65. So what is new in the Commodore 65, how to debug. Then we will have a lessons on graphics, 1 lessons on sound, maybe 1 of interrupts. I'm still not that far, so it depends on if I am at that far at that level or not. And basically that's it. So see you in the next lesson. Bye.